Welcome to module 6 of database management systems. This is the starting of week 2. In week 1, we have done 5 modules. After the overview of the course, we have primarily introduced the basic notions of DBMS, and we have discussed about the relational model, the fundamentals of it. In this background, in this week, we are primarily focusing on the query language, the structured query language SQL. So, all the 5 modules will relate to discussions on query language, and this module 6, 7 and 8, the 3 modules will introduce SQL at a first level, and the last 2 modules 8 and 9, I am sorry 9 and 10 will discuss about intermediate, that is somewhat advanced level of features in the SQL. The objective of the current module is to understand the relational query language and particularly the data definition and the basic query structure that will hold for all SQL queries. Particularly this the modules this week would be important for writing any kind of database applications, querying the database to find information from the existing data and to manipulate it. So, please put a lot of focus in the whole material of this week and practice them well to understand the basic issues of database systems in a depth in a well oriented manner. In this module, we will first talk about the history, and then we will see how to define data and start manipulating them. SQL was originally called IBM SQL language and was a part of system R. It was subsequently renamed as structured query language, and like any other good programming language that we have, SQL also gets standardized by ANSI and ISO, and there have been several standards of SQL that has come up, with SQL 92 being the most popular one, and the commercial system, most of them try to provide support for SQL 92 features, but they do vary between themselves. So, it is possible that the examples that we show here may or may not all of them execute in the system that you are using. So, you will have to look at what standard your system is actually following. Okay. So, the first what we will talk about is DDL, data definition language. As we had discussed earlier, this is the features to create the schema, the tables in a database management system. So, it allows for the creation or definition of the schema for each relation that we have in the database. It specifies the domain of values associated with each attribute of the schema, and it also defines a variety of integrity constraints. Later in the course, we will see that it also has to specify other related information like indexing, security, authorization, physical storage and so on. So, first the domain of possible values, we have already specified that every domain in SQL is more of an atomic nature. So, they are more like the primitive or built-in data types of languages like C, C++, Java. So, the common domain types are character, which are basically strings of character having a certain length. Then you can have variable character string, which means that the length here specifies that the maximum length that the string can take, but a string could be shorter than that. integer obviously, then small integer which in a system may give a smaller range of integer values. Then there is a numeric type which is often very important, which says what is the precision of the numbers that are to be written in this format, stored in this format. So, D basically gives that precision value and P gives the size. Then you can have real and double precision numbers, you can have floating point numbers and so on. And there are some more data types which we will discuss later in the course. Given all these domain types, so what we will try to do is, here is a schema for the university database, which has multiple different relations designed in that, showing the attributes and marking out what are the keys and what are the foreign keys. So, we would take examples of some of these and try to code them in the SQL. Now, to create a table, this is how you go about. The SQL keyword create table is the basic command. So, with the create table you have to specify a name. Here the name that is given is in terms of this name R, which is the name of the relation, and then you provide a series of attributes separating by comma. AIs are different attributes, and for every attribute there is a corresponding type, domain type specified. So, it says that A1 is of domain type D1, A2 is of domain type D2 and so on, and all of these attribute descriptions are then followed by a series of integrity constraints. It is possible that a create table may not provide any constraint, but often you will have a number of constraints to work with. So, here is one example. So, in this we are trying to code the creation of this instructor table. As you can see, it has 4 different fields: ID, name, department name and salary, and for each one we have specified the domain type. So, ID is char 5. This means that the ID of this table instructor will be strings of length 5, whereas the name or the department name are strings, but they have a maximum length 20, but they could be of variable length, whereas salary is of numeric type having specification 82. So, it can have 2 decimal places and be of size 8 maximum. So, this is the basic form of definition that we have for creating a table, defining a table or defining a schema. Now, we can add a number of integrity constraints to the create table. 3 integrity constraints we will discuss here. One is not null, one is primary key, and other third is foreign key. So, not null will specify whether a field can be null or not. Primary key, as we have seen, will specify the attributes which form the primary key, and the foreign key will specify the attributes which reference some other table and are key in that table. So, here is an example. The instructor in the instructor relation here, we had seen this part, the attributes. What we have added here is this not null. So, we say the name is not null, which means that in the instructor table it is not possible to insert a record where the name of the instructor is null, that is unknown, but it is possible. The same thing is not said about department name, same thing is not said about salary. So, it is possible that these could be null. Now, we additionally say that primary key is ID. So, this field ID is a primary key, and it is a property of SQL create table command that if an attribute is referred as a primary key, then it cannot be not null. So, you do not need to specify, that is here you do not need to write not null, because it is a primary key, it will be known to be not null, because certainly we have discussed that key is the distinguishing attribute in a database table. So, it cannot be null. So, it will not be able to distinguish. Similarly, we have the third integrity constant, which is foreign key, which says that it is referencing this table department, and the foreign key of this is here the department name, the dep name. This particular field is a foreign key which is a key of the department table, and so we will be able to refer this from this table as a foreign key, and we know that it will be a key in the department table. So, these are the ways to specify the integrity constant. So, here are a couple of more examples. So, I will not go through them in detail. I will request you to take time and carefully understand them. Again, these are about different relations that exist here about the student and about the courses that the student take, and in every case we have specified the set of fields that you have in the table in the design of the schema are listed in the create table. The ID information about the primary key is provided, and also the information about the foreign key. Here department name is the foreign key which is mapping to this point. Similar things can be observed about the takes relationship, which show the how students are actually taking courses. So, it relates different, it has a set of fields, but it has two kinds of primary foreign keys, one that relate to the student through the ID, and this combination of attributes which refer to the section. So, this is how different tables can be created using the data definition language. Here is a note that you should observe, that if you consider this section ID, the section ID is a part of the primary key, which means that two records cannot be same if they are different in the section ID, then such records are allowed. So, which means that it is possible that a student can attend or take a course in the same semester, in the same year, with two different section IDs, because they are primary keys. So, they can be different. So, if we drop this from the primary key, then we will enforce the condition that no student will be able to take a course in two sections in the same semester and the same year. So, these are the different design choices that we have, and we will move on. Here is one more example trying to show you the create table command for the course relation that we have in the university database. Moving on, let us look at how to update or actually put in different records in a table which has already been created. The basic command is insert, and the keywords for that is insert into and values. In between you write the name of the relation where the record will have to be inserted, and then the values will have to be put as a tuple in the same order in which you have defined the attributes of that relation. And certainly each of the values, like this is ID value, next is the name value, the department, the salary, each one of them should be from the same domain type as has been specified during the create table command. So, these things we will have to remember, and So, every record will get inserted through one insert command. Similarly, a deletion can be done by delete from students. If you do delete from students without specifying which record you want to delete, basically all records will get deleted. We will see how selective deletion will happen, that will come on later. Drop table is a command to remove a table that has been created can be removed from the database altogether by doing drop table and the relation name. You can also change the schema of a table by using alter table. So, the form is alter table is the keywords. You can add a new attribute to relation R by writing the name of the attribute and the domain of the attribute one after the other. Similarly, it is possible also to drop an attribute that already exists, and the syntax for that will be alter table, the relation name, drop is the keyword and the name of the attribute. Mind you, all database systems may not allow you to drop an attribute, to alter table to remove attributes, and so it works in some and it does not work in the rest. Now, let us, so that was about the definition of the table and the basic definition of the data. So, now we will get into the basic query structure, which is with tables with existing data, how do I query and find out different information. So, the structure of an SQL query, and this you should observe very carefully, is normally said to be select from where. Colloquially, we will often say let us have a select from where. So, it has three keywords: select, which is followed by a set of, this is a set of attributes. So, this specifies that when a select query runs, it will finally give us a new relation, and in that relation the attributes that will be available are the attributes that feature in the select list. The next clause or the next keyword in this is from, which specifies a set of existing relations. So, R1, R2, Rm represent different relations, and these are the relations which will be used to actually find the information, extract the information. Finally, the where clause has a predicate, has a condition which specify that what condition has to be satisfied, so that certain tuples from the relations R1 to Rm will be chosen and put in this new selected result table in terms of the attributes A1 to An. So, this is the basic understanding of the or structure of the SQL query, and naturally, as I have mentioned, that will result in a relation. Now, we will go over each and every clause carefully. The select clause, as I said, will list all the attributes. So, it is like a projection in terms of the relational algebra that we have done. So, if we write select name from instructor, then this will result in finding the names of all instructors from the instructor table, because this is this you know is a relation, because it is happening, it is featuring in the from clause, and in select we are saying that the attribute that we want to select is the attribute name. So, it will, the instructor table has 4 attributes: ID, name, depth name and salary. From that it will simply take the name of the instructor and list that in the output table. So, the basic form of selection that happens. At this point, you may also note that in SQL everything is case insensitive. It does not matter whether you write in uppercase or lowercase. So, you can choose the style that you prefer to use. This is a very important factor that you should keep in mind, that we said while introducing relational algebra, that in the relational algebra everything is every relation is a set, and which means that according to set theory, we cannot have two tuples in the same relation which are identical in all its values, because set theory does not allow that. But please keep in mind that SQL actually allows duplicates in relations. So, it is possible that in the same relation, in the same table, I may have more than one record which are identical in all the fields, in all the attributes of that table. And this will have lot of consequences, and we will see how often this property will have to be used. So, if you want a typical set theoretic kind of output, that is, if you want the relations to be the result to be distinct, all records to be distinct, then you have to explicitly say that you want distinct values to be selected. So, all that you are doing is you are after select and before the attribute name, you introduce another keyword distinct. So, select distinct dep name from instructor will actually select the departments of all instructors, and if it just selects department name of all instructor, then it is quite possible that the same department name will appear number of times, because every department has multiple instructors. But when we use distinct, then the every name will feature only once in that selection. Then you can also specify another keyword all, which ensures that the duplicates are not removed. So, if you do select all dep name, then all the names will feature with duplicate. So, if some department had 3 instructors, the name of that department will feature thrice. You can use an asterisk after select to specify that you are interested in all the attributes that the relation or the collection of relations in the from clause has. You can also specify a select with a literal and without a from clause. If you do that, then it will simply return you a table with a single row having that literal value, and you can also rename that table using what is known as the as clause, as command. So, this will give you a table foo where there is only one row, and that row has an entry 437. You can use that for other purposes also. You can do a select of a literal from a table with using a from clause, wherein you will get a single column table where as many A's as there are records in the instructor will be produced. Select clause can also use basic arithmetic operations. For example, here we are showing a select where the third attribute, as you can see, the third attribute is salary by 12. Assuming that the instructor table has a salary number which is annual, salary by 12 naturally give you the monthly salary. So, those such arithmetic choices can also be made. You can also rename that field, that particular salary by 12 field in salary by 12 field by a new name. As I said, as can be used to rename. So, if you use that, then when you get the output, you will get the column names as ID, name and monthly salary, and in monthly salary you will actually have a computation which is salary by 12. And in the same way you can use multiple different kinds of arithmetic operators. Now, we come to the where clause. Where clause specifies the condition, is a predicate which corresponds to the selection predicate of relational algebra. So, it will specify some condition. Here is an example. If we want to find all instructors from the instructor table who are associated with computer science department, then you can say select name from instructor, and to specify that they are from the computer science department, you will specify department name is equal to computer science. So, this will ensure that you select the records only when this condition is satisfied. So, all records for which department name is different from computer science will not be included here. Okay. You can also write predicates using the different logical connectives and, or, not, and so on. So, here is an example where you are finding all instructors in computer science with salary greater than 80,000. So, here we have used AND clause. So, only records where the department name is computer science and salary is greater than 80,000 will be chosen in the result. So, and then the projection will be done on the name of those instructors. You can apply comparisons of arithmetic expressions. So, where clause can really write different kind of things. Finally, the from clause is sets all the different relations from where you are actually looking for the records. So, it kind of corresponds to the Cartesian product of the relational algebra. So, if we want to say compute instructor Cartesian product teaches, then we can say select star instructor one table comma teaches. So, this will choose records from instructor relation as well as from teachers relation, and in all possible combined way it will put them in the output. We have used a star. So, all fields of instructor and all fields of teachers will be there in the output. And since some fields may have identical name like ID, there is an ID in instructor and there is ID in teachers, they will be qualified by the name of the relation. From can have one relation, two relation, any number of relations as you require. So, this will cause the Cartesian product to be computed, which may not be very useful as an independent feature, but we will see in the next module how it can give very important computations in terms of computing joins and so on. So, here is an example of the Cartesian product that we talked of. So, here is the instructor relation, the teachers relation, and as you can see, when we have done this Cartesian product, that is select star from instructor comma teachers, then all fields, this is the ID of the instructor, it has, there is an ID in teachers. So, that is also specified here, qualified by the name of the relation, whereas name comes in directly because there is no attribute called name in teachers. The department name comes in directly, salary comes in directly, course ID comes in, section ID comes in, semester comes in, year comes in, and so on. And the combination of all tuples in the instructor relation against all tuples of the teachers relation, all possible combinations have come in this result, which eventually is the Cartesian product of the relational algebra. So, this is what we have. To summarize, we have introduced the relational query language and particularly familiarized ourselves with the data definition, that is creation of the table, creation of the schema with the attribute names, domain types and constraints, and the updates to the table in terms of insertion and deletion of values or addition or deletion of attributes or removing a table altogether. And then we have given the basic structure of the select from where query of SQL, which will be the key language feature of a query language that we will continue to discuss all through this course.